Okay, well, it is absolutely a pleasure for us today to be able to be joined by the mighty Metropolitan Transportation Commission here in actually in my area, in the Bay Area, and to be we have a couple of really major representatives that are here from the local host organizer, and I really want to recognize them. Alex Bockelman, who is, and Luz Campos, who are with the what we affectionately call the MTC, and they are the Metropolitan Planning Organization for the San Francisco Bay Area, which is a 9-county area, and really have been very instrumental in helping to bring together what has been a very unique regional transit consortium for purposes of this particular challenge. And then we're thrilled to be joined today by Sadie Graham. And Sadie Graham is with BART, one of the altogether 7 transit agencies that have been who have directly participated in the consortium. And Sadie is with BART, and I've been saying it throughout, but literally very thankful to the leadership at BART. Bob Powers, the president CEO at BART, their general manager, was really the first to sign up along with AC Transit directly, but then honestly really did the push to say, we really need to look at how we bring this together as a regional transportation consortium around the critical area of workforce. It was instrumental in the consortium that you see today. So we're extremely appreciative. That consortium consists of AC Transit, BART, the Bay Area Rapid Transit, Caltrain, Golden Gate Bridge Highway and Transit District, Samtrans, many affectionately here across MUNI, the San Francisco Municipal Transportation Agency, and Santa Clara Valley Transportation Agency, VTA. And the team that you see represented here today actually is representative of all of those groups. And so we have 4 members of what they have termed themselves the Transit Titans, okay, that are here today, Transit Titans. And I'm going to, it gives me a pleasure to really be able to introduce them, okay? And there are 4 of the 6 members who are able to make the presentation today, and that is Alexander Hergy, Jaylene Perez, Nicholas Wilsey, and Sahid Sandhu. So let me start by saying their theme. And their theme, this is an extremely transit rich, if you will, a metropolitan area. And no question has been riveted by the pandemic. And one of the things, what they really focused on is this whole concept and this imperative of return to transit. And their focus and where they came in on is a focus on the reliability of communications that occurs between transit agencies and the consumers. And so their challenge resulted in an interface that includes a better predictive algorithm that gives more accurate times to riders about when to expect a bus to arrive. And you'll be hearing them speak about that and why they settled on that and some of the work that they put into really bringing it to fruition. So let me give you a little background on, let me start with Alexander. Alexander Hergy is a sophomore at Northeastern University in Boston, studying public policy, political science, and economics. Alexander currently works with MUNI, the San Francisco Municipal Transportation Agency, on the Potrero Yard Modernization Project. He previously served on the San Francisco Youth Commission, where he worked to speed up and improve bus lines used by youth and students across San Francisco. And he started work at MUNI's Youth Transportation Advisory Board, where he worked to make MUNI free for all youth 18 and under and to improve transit accessibility. And he's also served on the San Francisco County Transportation Authority's Sales Tax Expenditure Advisory Committee. So he is no neophyte, if you will, to the world of transportation. Next, I'm going to, and so Alexander, thank you for being a member of the team and with us here today. Next, Jaylene Perez. Jaylene is currently a public service trainee in the Human Resources Department at MUNI. She's recently finished her first year of college at San Jose State and is currently studying business administration with a concentration in management information systems. As an everyday commuter that uses public transportation on a regular basis, she became interested and taking it deeper. And so therefore for her, this innovation challenge has really helped her to learn more about the industry. And as she's expressed that she's been very excited by the many opportunities that are really coming as a part of her participation in the challenge. And then, so Jaylene, thank you for being with us here today. And then Nicholas Wilsey. Nicholas recently finished his sophomore year at Cornell University, where he's majoring in urban and regional studies. He's had the opportunity to work in multiple planning contexts, including projects focused on transportation, open space, and housing. And last summer, Nicholas, very interesting, worked with Slum Dwellers International in Kenya to engage in settlement upgrading initiatives. And at Cornell, he's also minoring in computer science and interested in how technology can be used to improve urban life and the planning process. And in particular, he enjoys working on projects in transportation that are with transportation data to derive new insights, new fact-informed insights, and understand systems better. And then last but not least, Sahej Sandhu, okay, who is working towards his Bachelor of Science degree in engineering from the University of San Francisco with a focus in civil engineering, along with acquiring his GIS certification, Geographic Information Systems. And most recently, he authored an extensive research paper on the differences between warm mix and hot mix asphalt, focusing on the usability of the asphalt and the greenhouse gas emissions each type of asphalt produces. Sahej's passion for engineering, excitement about the transportation industry, and his desire to work hard and learn has led him to be a participant in the. So with that, I will now leave it to the Transit Titans. You will hear directly from the Transit Titans, and we're taking it away to their 3-minute compelling statement. Take it away.
Hi, I'm Jaylene Perez, and I decided to be part of this innovation challenge because I am a everyday rider myself using public transportation.
Hi, my name is Alexander Hergy. I decided to be part of the IYAI Innovation Challenge because I am someone who's always been interested in public transportation.
Hello, my name is Sai Sandhu, and I joined the Innovation Challenge because I'm an engineering student and a lot of my projects revolve around transportation engineering.
Hi, my name is Nicholas Wilsey, and I wanted to join this challenge because I'm really interested in public transportation and thinking about pursuing it in my career.
We have had the opportunity to work with 7 different agencies to come up with our innovative solution to implement in transportation agencies. Currently, the biggest problem with transportation agencies is that they're not giving accurate information to their current riders, which frustrates the rider and makes them believe that transportation agencies don't have a reliable system.
Most of the existing bus prediction models that the agencies that we worked with use only consider 2 factors. They consider the real-time location of a bus and the time of day. They use those factors to provide real-time estimated time of arrivals for transit vehicles along their route. However, we've experienced how inaccurate those are, and studies from the transit agencies that we've worked with also highlight that. What we chose to do is we thought about other pieces of information we could use to build a more accurate prediction model for real-time live ETAs. In addition to the 2 pieces of information, the time of day and bus location, we also consider real-time traffic along that route and the bus crowding for each individual bus. These factors give predictions that are significantly more accurate. To highlight the potential of this technology, we chose to implement our new model on one route in San Francisco, the 25 Treasure Island.
With over 100,000 new data points, our interface is much more accurate than what is currently in use. It is easily implementable and cost-effective, so agencies will have no trouble integrating it into their current systems. Our design is equity-focused with a focus on underserved communities. With our innovation, everyone, including those without a smartphone, will be able to rely on more accurate and transparent data.
Our new customer information system will provide 3 new and improved ways to provide customer information for transit riders directly to the riders who don't have it right now. One way that we are planning to do this is by installing new, bigger, and more capable signs at bus stops that currently have only single-color LED signs on them. These new larger LCD displays will be able to show different languages.
On behalf of the Transit Titans team,
Thank you.
All right. Thank you so much to the Transit Titans. The floor is now yours, and you may now share your screen to deliver your pitch. Thank you so much.
Good afternoon, and welcome to the Transit Titans IYAI Innovation Challenge presentation. My name is Alexander Hergy, and today we're going to be giving you a presentation on how we have an innovation that we think will improve transit availability, help rebuild ridership to systems. Next slide, please. So here's a brief overview of what we're going to be presenting to you today. We're going to share who we are. We're going to share what the problem we're hoping to address is. We're sharing some of the impacts that this has on riders. We're sharing our solution, the Titan prototype. We're also going to show you guys how we hope to scale this innovation up. And we're going to share how it addresses systemic inequities and makes the transit systems that we hope adopt this technology a more equitable system. And if time warrants, we're going to show you guys a little special something of a demo at the end.
Let's meet the team. My name is Sahaj and my teammates are Alexander, Jaylene, and Nick, and together we are the Transit Titans. Next slide, please. As a group, we all rely on public transportation and have experienced the frustrations of inaccurate estimation times, buses not showing up, which are ghost buses, and we notice that people without smartphones do not have clear access to updates regarding their bus route, leading to a frustrating experience. This is the reason why we're all passionate about this challenge and our innovation. Next slide, please. However, don't just take our word for it, but consider the story of these two ladies, Jill and Jane. We visited the Treasure Island bus route and met them. Jill and Jane both expressed frustration because the bus had arrived earlier than the posted time on the signage. This led them to be late for work and their destination, and they both wished there was a better system in place. Also, keep in mind that Treasure Island is an equity priority community, and the Treasure Island bus route is an equity priority route. However, the only signage is a paper signage that obviously cannot receive updates, and you could see that signage on the right picture. This leaves riders like Jill and Jane without updates on their bus and can lead to an undesirable experience like this one. Next slide, please.
As mentioned, we have focused on the 25 Treasure Island route, which serves equity priority community. And it seems like this is actually the only way people get to San Francisco without using the freeway. However, it is unpredictable due to the Bay Bridge traffic. Next slide, please. Here you can actually see an example of inaccurate predictions customers get, customers like Jill and Jane. Please look at the picture on your left-hand side where you can see Muni predictions say the bus will arrive in 6 minutes. And on your right-hand side, you can see that Google Maps shows the stop and go traffic of the Bay Bridge, in which the bus actually showed up in 11 minutes. Something that these transit apps don't show customers are the ghost buses, which are buses that are scheduled and ETAs count down, but the bus tends to not show up. And diversions, which are buses that skip parts of the route and don't have accurate predictions. This ruins the perception when riders are expecting a bus and the buses on the app disappear. Next slide, please. Only 21% of San Francisco stops have ETA information. We can see that this piece of paper does not have real information for customers to rely on the bus getting there on time. Seniors and other riders without a cell phone are left in the dark, signs to have limited languages, and have limited communication alerts. So what does this mean? That the current system is not an equity-based focus for its everyday users. Next slide, please. The problem with this existing system is that it only takes into account the vehicle time, location, and historical traffic trends, but there's at least 3 factors that can improve the accuracy of this. Therefore, we believe that there is more data that's required to make better predictions for its users. Below, you can actually see a tweet from SFMTA where they mentioned that one of their vendors had lost historical travel time data, leading to unreliable predictions for Muni users. Next slide, please. In addition to these inaccurate predictions, ETAs do not consider the live conditions such as traffic, crowding, and the weather. You have seen it, you have heard it from customers about the inaccurate predictions. So in a little, we will show you the impacts these inaccurate predictions have on customers. Next slide, please.
As Jaylene said, now we will talk about the impacts of unreliable prediction times. Next slide, please. As you can see, 92% of riders, like Jill and Jane, say that accurate arrival prediction times are extremely important. However, only 49% of riders rate arrival prediction accuracy as good or very good. This depicts how riders care about the arrival prediction times, but are unsatisfied with the current system. So now we will talk about the solution that we came up with, which is our Titan software. Next slide, please.
Okay. So what we did is we looked at the existing system and we built a new system, which we're calling the Titan software, from the ground up for our 25 Treasure Island route that we feel addresses all the challenges that we've heard about before in terms of inaccurate predictions, ghost buses, and customer information. Next slide, please. So kind of the front end of our software is a website that we built. You can see it right here. There's a landing page and an information page. They're both designed for use on mobile phones because riders at a stop aren't going to be on their computer, obviously. Next slide, please. So we started at the very beginning, and we thought about what information does our prediction algorithm need to deliver the most accurate predictions to riders. On the left, you can see the existing system has 2 inputs. It has vehicle locations as they're going along their route. It has the time of day, and it uses that to balance it with historical trends, to estimate what the traffic is, maybe what the crowding is, but it's historical trends. And as we know, in a city, historical trends aren't very accurate. There can be a car accident and that throws everything off. So on the right, we've got our Titan software. It includes vehicle location and time of day, but it also includes real-time traffic along the route and crowding on each bus along the route. By adding these additional sources of information, we've created a prediction algorithm that is more than 20% more accurate. Next slide, please. So to do this, we needed a lot of data to train our model. And so over the past month, we've collected over 100,000 data points for the 25 Treasure Island route in San Francisco. Each of these data points includes a vehicle's location, its eventual arrival at the stops along the route, traffic conditions in real time, and the occupancy level of that bus. And with all that information, we were able to build a polynomial regression machine learning model to estimate predictions for each individual stop. Next slide, please. So with those predictions, we wanted to make sure that they're accessible to riders. And so we developed a straightforward front-end website that has a landing page where you can select direction and stop, and then gives the prediction arrivals from our model. As you can see on the right, we've broken up the predictions into live buses and scheduled buses. If a bus hasn't left the first stop, we make sure that it's a scheduled bus. That addresses the challenge that many riders face with ghost buses. A bus is supposed to leave the first stop, but it just never shows up. And so we want to manage expectations and make it extremely clear has the bus actually started the route, or is it just supposed to start the route? Next slide, please.
So the second component of this new Titan model, this new Titan system, is the interface, what the users actually see. So there's a little bit of recap. The current interface, for the feedback that we've collected, can be confusing to riders because it either reports data in a more confusing fashion, can be difficult for non-native English speakers to use. For example, the sign that you see on this, the image you see on this slide cannot physically display characters in languages like Chinese, and it cannot display characters like with accents like there are present in Spanish and other languages. That's not good if you don't speak English. Furthermore, these signs are unreliable due to power problems, water intrusion, but most importantly, they're unreliable because the predictions that they have often aren't great. We've addressed this with the model that we're using to collect those predictions. However, these signs actually need a bit of an update to be accurate and usable for riders. Next slide, please. So what are we actually looking to improve here? Well, looking to give more accurate and better data to all users through more signs on the street, in shelters, and at bus stops, a better mobile application for those using mobile devices, and enhanced onboard signage like the sign you see in the image to the right of the slide. Next slide, please. So this is an example of a sign that we hope to install on the street. This is currently being installed by San Francisco Municipal Transportation Agency, and it shows when the bus is going to arrive. It also shows what the crowding levels of the bus. It is capable of showing stuff like graphics, capable of showing stuff like maps for route detours, and capable of showing other system service alerts. It is also permanently powered, which makes it a little bit more hard to install, but we have a solution to that. Next slide, please. This is an example of an e-ink sign currently being trialed and used by the MBTA in Boston. It shows the same quality of information that the previous sign showed. However, it is easier to install, solar powered, and is able to be installed on pretty much any single stop throughout the system. Quick to set up in areas that do not have the infrastructure ready, but yet warrant and need and deserve these investments. Next slide, please. This is an example of the signs you want to install on the buses. It shows where the bus is, shows what the next stop is, shows what the connections that you can make at the next stop is. Next slide, please. It more importantly shows what the times are for the next bus to arrive at that transfer stop is. So you can quickly and seamlessly know where you're supposed to go and what you're going to take. Next slide, please. It also shows the map of what the bus, of what the location is going to look like at that next stop, so you know where to go to actually get your bus that you're trying to transfer to. Next slide, please. Okay, so how are we actually going to implement this and scale this? Next slide, please. Well, the absolute genius part of this Titan model is that it uses pretty easy to implement code that works with free data standards. It also uses physical components like these signs that are already proven and tested, so we know that they're actually ready for service and ready for the real world. Also, multiple agencies adapt this system. There can be a bulk order that can drive down costs because due to economies of scale. Next slide, please. So this is our SWOT analysis. We've discovered that our system is really strong in the sense that it uses existing data, it uses the infrastructure. So really the code is like the only part. We're expanding, of course, these onboard signs, but it's already proven technology, so it's pretty easy to implement. However, we do suffer from weakness in the sense that the traffic data does cost a bit of money. That can be a bit of an expense. And the challenge that we face also on the lines of money is that us Titans, our budget is currently zero, and agencies are in long-term contracts, so it makes it a bit harder to switch. However, there are opportunities in the sense that we can modify the technology to be even better. We're looking at adding weather suit to the model. We're looking at adding stuff like operating driving behaviors, see how an operator that is assigned to that vehicle block and that vehicle run actually drives to better refine and better nail down when that bus is going to show up. Next slide, please. So what are some of the equity benefits and what are some of the ways that our new system works to address systemic inequities in our society? Next slide, please. Well, the system really works to help those riders that work in essential jobs that rely on off-peak service, jobs that are not 9 to 5s. Those people who work those jobs need to make sure they get their bus when it says it's going to come, because there generally are worse headways and worse service at the times they need to get to their jobs. Next slide, please. These people also have much higher stakes than your standard old 9 to 5 job employee. If you're working in the service industry and you're late to your job, it is super easy to get disciplined and possibly lose that job because you're late. Same thing with if you're a student. If you're late to school, that can result in multiple tardies, which can result in detentions and other sort of forms of discipline. It is critical that these riders all get to where they need to go with confidence and know when their vehicle is going to come. Next slide, please. Furthermore, we're eliminating the digital divide with the Titan model by ensuring that there's high quality signage all throughout the system. We're eliminating the problem where riders with a cell phone have way better system information than those who do not have cell phones. By putting very good signs on the streets, on the buses, we are eliminating this problem. Next slide, please. Finally, we want to make sure that all areas of any community get access to high quality information. On the left is a photo from a study of San Francisco that showed that areas that are in the SMTA zone service equity strategy and areas like the Bayview that have suffered from historical disinvestment due to racist motives lack amenities like bus shelters and arrival signs. We're getting rid of that through measures like the e-ink pole signs that can be installed very quickly, and eventually through shelter signs. We want to get rid of the stuff on the image on the right, which is a simple sticker. That's no good. We want to put signs where those would go. Next slide, please. We want to thank you for your time today, and we encourage you to pull out your cell phones and scan the QR code to actually try out our software. It's ready, it's running. You can give it a whirl and see when the bus, due to the traditional way, thinks it's going to come, and you can see when the bus, through our predictions, are actually going to come. And we thank you for your time and your attention, and we hope to be able to expand our software soon, and I hope to roll out sort of mini stopgap measures to install it through QR codes at places like Treasure Island do not have real-time screen. So we thank you for your time, and we are available to answer any questions you may have.
Perfect. Sorry, I have the lawnmower behind me. We're going to take a moment to reset the clock here, and we're going to open up this portion for 15 minutes of judges Q&A. So I'll hand it off to Leslie. Go ahead and take it away.
Thank you, Trey, and good afternoon to the Transit Titans. I'm pleased to be joining you from San Francisco, where the sun is finally peaked out and it's 59 degrees. So greetings from the West Bay. I'm a resident of San Francisco, and this project really resonated with me. In my past life, I had been the regional administrator of the Federal Transit Administration, San Francisco's office. And I am a regular, if not daily, Muni and BART rider. So I have had the distinct honor of serving as the lead judge, and I am joined by a very talented group of distinguished transit professionals. We will pose, as each of the other four judges, to pose a question. But before I do, let me again thank Alex and Luz from MTC and Sadie from BART. Your participation, I think, is representative of the stellar assistance and support that you provided to the team throughout this challenge. So having said that, let me just first turn to one of our judges, Julia Gessner. Julia is joining us from Steeny, Dallas. And Julia serves as the Director of Administration for TransDev US. Julia, a question for the Titans?
So I think that this is a really incredible program and very much needed as we're looking to get more passengers on transit. How would you, and did you consider at all, how you would communicate with current and potential riders that there's now an application that will give them better real-time information if this were to actually be launched and out in the public?
Thank you for your question. How would we communicate to riders that this would be a more accurate system and that it's available? We're proposing actually right now, as you saw in a couple of photos on Treasure Island right now, there's just simple flyers that estimate when the bus is supposed to come. We're proposing rolling out sort of QR codes so we can tape those signs, stick on those signs with a more weather resistant method to give them the actual data, because currently there's nothing there that's real time. And then going forward, we would hope to partner with a couple of agencies that are currently going through sort of customer information system refreshes and updates, to work with them to actually improve, to put in some parts of our model, which is to say we want to, it's a fairly quick fix per se, to put in something like the real-time traffic data, because as more systems move away from, as more and more systems are sort of realizing that something like headway mode is a better way to operate your service rather than sticking to a complete 100% fixed time point methodology of running service, it is easier because the operating sort of method of agencies is switching up. It's easier to sort of say, look, what if we tried to actually make it so that there's a comprehensive sort of switch up of how you even measure the vehicles, and so it's easier for us to sort of go to the agencies and be like, hey, we have a technology that can work with your new headway mode to predict when the bus is going to show up. This is how we think it should be done. And that's how we're sort of planning to do both the pitch to the public and also pitch it to the agencies as a sort of like, look, we're already updating the system in terms of how buses are scheduled. Let's also make sure that update carries over to how customers know when the bus is supposed to come up. And then again, rolling out some QR codes initially for where there aren't predictions to make sure that riders with cell phones can access that. And then working with agencies to hopefully put some of those like e-ink signs up in other places.
Thank you. Just as the team includes representatives at schools on the East Coast, the judging panel also has representatives from all around the country. I'll call on our next judge from the Boston area, Andrew Brennan. Andrew is a vice president at the firm of HNTB, and there he's engaged in its national transit and rail practice group. Andrew?
Thank you very much. Really fascinating, really interesting. I'm curious about, you talked about the, I think I should call them weaknesses, but that one was the traffic data, real-time traffic data you had to pay for. It's a purchase service, right? And the other was weather. Well, the other was a piece of weather. Where would you get, how would you get weather data? And I'm thinking more so weather than it's climate data, right? Like condition of roads. Where would that data come from?
Excellent question. Thank you. So first part of that, the traffic data. One challenge with traffic data is that public agencies don't have it. It's created by Google Maps and TomTom and here and all these private companies that sell it for a price to make money. And so when we built this model, because we were only doing one route, we were able to, the frequency with which we got the traffic, it was every minute. That was, we were able to do that for free. But if you were to scale this up, you'd have to pay for that. I would argue that that's a worthy cost in terms of the improvement to predictions, but that is a cost. And then weather data is also relatively straightforward to implement. There's a lot of existing APIs that are available that are free. Actually, in one prototype earlier, we used the weather API, but the thing is, in San Francisco over the month, the weather just didn't change that much. So,
lucky you.
Right. So yeah, weather can be added pretty easily, and my understanding is it's free up to any level, but it might be a small cost.
So the thing that's interests me is it really just the weather, that it's raining or it's snowing or it's cold? Isn't it more about condition on the road, that there's flooding on the road, there's ice on the road, there's whatever on the road? That's not really a purchasable data point, correct?
So the conditions on the road wouldn't be included in weather data. I mean, if it says it's snowing, that's kind of a proxy for the conditions on the road. And then also that real-time traffic, if it's icy on the road, cars are going to be going a lot slower. So you're able to get that information through those other sources.
There you go. Good point.
Thank you. My friend Alex Bockelman is on the phone, but I'm smiling and I know she must be, because this is just yelling for MTC involvement. Sorry, Alex, but our next judge, I know she's chomping at the bit to jump in here. So let me welcome Greer Johnson Gillis from the Jacksonville Transportation Authority, where she serves as the Senior VP and Chief Infrastructure and Development Officer. Greer?
You are right, Leslie. I am chomping at the bit. MTC, well done. Very impressive. And Nick, a shout out to you, a phrase I haven't heard since college, polynomial regression. Thank you. I have so many different questions, but I'm going to stick to the infrastructure side. Thank you for talking about the infrastructure availability. and recognizing the infrastructure needs to actually deploy this. So can you expound a little bit more? You've laid out what is needed to deploy this across San Francisco. How are you intending to do this and actually take this across San Francisco, especially given your budget of zero? What's your plans?
Okay, so that is a very good question. So for us, with a feeble budget of zero, the QR codes are pretty much what we've got in the tank right now for sort of a quick launch. However, we would intend to partner with an agency, someone like the SFMTA, which has already piloted the signs that we talked about. Because that allows us to like do a little bit of proof of concept, because those signs are relatively new and those signs are relatively easy to sort of program to allow us to test that technology and test the new predictions model. As for going cross country, that system on that photo that we shared that the MBTA is using, that's a pretty modular system that can be installed like on any sort of like street sign pole, be installed in like a no parking sign pole, like be installed on any sort of like, theoretically you could probably mount on like a street light pole. So that's a pretty modular way to do it. That's pretty low cost as well for implementation, because you don't need to hook up, you don't need to go to the utility provider, pray they're not going to delay your project and have them hook up an electrical line. That's solar powered. It's kind of like, it's a very sort of much like you open the box, you put it on the pole, and then you set it up and make sure it has a data connection, then you're done. So that's something that we'd ideally look to partner maybe with MBTA, maybe with a different agency that's testing those signs already, because those are still fairly new to the States. And that would be an easy way, again, proof of concept, and then pitch it to other agencies and be like, look, we've done this here. This is how you can do it. And then again, sort of go out the point that we made about sort of the bulk procurement and so the economies of scale point. As more agencies hopefully become more interested in this, because it's using existing technology, existing like hardware, it's easier to sort of know what vendors you can go to. So we're proposing to basically roll this out as like use a proof of concept for the Titan model, the actual software, then go to agency that has the firmware and be like, look, can we partner with you guys? We think we have this sort of new smarter way to roll the predictions, and work with them to see if we can get access to the hardware, because with that budget zero, like we said, there's really no way for us to actually acquire one of those signs. That's something an agency could do. That's not something that a group of 4 college students and transit sort of technology know-hows could really do. So we would look to partner with an agency to test that technology on the firmware, and then sort of expand as more agencies become interested in what we've actually built and developed for the community.
Excellent.
Thank you. We'll next receive a question from our 4th judge, and she is Alicia Kane with Cubic Transportation System. And at Cubic, she's the head of UMO Solutions and Market Development. And I think I heard a reference to UMO in the presentation. So take it away, Alicia.
Good afternoon. Can you hear me?
Yes.
Okay, good afternoon. Great presentation. It's right up my alleyway. I work in fare collection, and my history is in technology. So this is one of the problems that I used to try to solve, but we would, as agencies, collaboratively try to work with various entities, including other agencies. We bring in like hackathon type local groups to help solve problems like this. And I think you guys did an outstanding job in presenting not only a problem, but also coming up with solutions that understanding technology can be a divide for some communities and some just people in general. So good job in working through this process. And I see, some reference to working with other agencies. Have you all had the opportunity to work with open architecture type or in other mobility data type organizations? Have you all been exposed to those? These are areas where you can, work with other people who are trying to solve the same problem. It seems like there's a repetitive thread of people trying to solve the same problem and working together collaboratively. There are groups that allow you to do that. Have you been exposed to any of those groups? And you're in California, so I know Cal ITP is huge up there, and some other organizations, Mobility Data and others. So have you had experience working with groups like that?
So in the course of this project, we've primarily worked with transit agencies. We've working with the MTC, we had the ability to engage with not one, but 7 of the Bay Area's transit agencies. So a lot of what we learned and what we understood comes from the transit agency side. I think in terms of some of these other organizations and these other kind of pioneering data standards, definitely we were exposed to that to a certain extent, just as we tried to understand and parse what's the current public transportation data look like? How does GTFS data work? How does all that function and fit together into something that's a cohesive product for riders? I'm not sure if that answered your question, but
yeah. So I would just, as part of your next steps, offer up the opportunity to expand some of your knowledge base in that area by working with some other, the agencies have access to these other organizations, especially on the IT side. So I just offer up the, in your plans for next steps to look and look up, I have some lists. I don't want to name anybody on this, but I would suggest you look up and work with some of your scientific background and your ability to pull this together proves that you have the capacity to do some really good and interesting work. And so I'm just offering up the opportunity that you should probably look at other open data architecture type communities and pull in some of that knowledge as well.
Thank you,
Appreciate
Alicia.
that.
And since great minds think alike, my colleagues have usurped all my questions. So for the sake of time, as we move forward at every team, we will look to you to provide a 2.5 to 3 minute wrap up closing remarks from the team. Thank you. Take it away.
Just wanted to, of course, thank you, judges, for your time and for your questions and for your feedback. That was, of course, extremely helpful for us because we're thinking about, look, how do we want to roll this out? How do we want to expand it to the community? How do we want to make this actually something that is active and usable rather than just an idea? We've already made the proof of concept. We already done the development, but sort of you guys pushing it to sort of figure out and expand upon it, think about out of the box. How are we as sort of 4 college students going to expand this to those who need this transit service? We're incredibly thank you for your time and your questions and your feedback on that, especially as young people like us that we are of that group, but we realize that in order to fight climate change, in order to use sustainable transportation methods, we need to make sure that people have confidence in public transportation, have confidence in these systems that are there, have confidence in that they can use public transportation as an alternative to driving. And we are super thankful to you guys for your feedback and allowing us to develop this system that will go forward and make sure that people do have the confidence to know the bus is coming when it's coming. They do feel like they can use the bus as an alternative to driving. And they do feel like that public transportation is a real alternative that will help save the planet, help reduce greenhouse gas emissions from driving, and help bring back riders also from work from home and make sure that they feel like that transit is not something that's delay prone or unreliable because the predictions said are wrong. And we really are thankful for you guys to allow us to present this technology to you guys. And we are thankful to you judges for showing us sort of how and motivating us and pushing us in a direction to really figure out how we're going to market and develop this technology for the rest of the world to use. So thank you.
Well, thank
You're
you very much.
welcome.
And on behalf of the judging panel, let me extend my sincere thanks and appreciation to the Titan team for sharing your Sunday afternoon with us. Great presentation. We'll now turn back to Dr. Scott to close us out.
Thank you too. I'm just going to extend our thank you as well from Aya, and I can perhaps say this much. We always say at Aya that we dig deeper. So it's been about reimagining and rewriting normal, and part of rewriting normal is actually what are the implementation steps. And so as a major portion of what we're going to be doing moving forward is actually the challenge doesn't end, but it's just the beginning, and to really work with the agencies in terms of implementation. Okay, so thank you very much for your time, your thoughtfulness, and for the leadership that has been exhibited in the Bay Area to make this opportunity really come to fruition. So thank you so much, and go enjoy
Perfect.
the rest of your Sunday.
We'll see you all. Thank you for your
We'll see you.
participation. Bye-bye.
Thank you. Thank you. Thank you.